raise just one eyebrow, not both, but like just one. Okay. I was like, I don't know what that means. But so some people believe that the ability to taco tongue and evil eyebrow is something that you are born with. Is this true? Are the two abilities somehow related? Okay. So we would normally collect class data to fill in the following two-way table and Venn diagram. However, there's not enough of you to use that data. So this is called a two-way table. Okay. So this is called a two-way table. And you saw these back in geometry. You know, they were referred to as like frequency tables. So the data that we're going to use is that we have 15 people who can do the evil eyebrow and can taco tongue. There are 3 people who can evil eyebrow and not taco tongue. And there are 5 people who can taco tongue but not evil eyebrow. And there are 7 that can't do either. Okay. And with two-way tables, you always want to total up each column. Okay, so for instance, we got 15 and 3, which is going to give me 18. 5 and 7, which is going to give me 12. 15 and 5, which is going to give me 20. 3 and 7, which is going to give me 10. And if I add both of these columns, they both equal 30, which is the total number of participants. Okay. If I'm going to do a Venn diagram, remember Venn diagrams are those two circles that overlap. The overlapping part is the something that they both have to share. So, for instance, the 15 is going to go in there. Okay. And then we have 5 who said yes, they can taco tongue. And then we've got 3 who said yes, they can evil eyebrow. And then we have 7 that can't do either. So they're outside of the circle, right? Okay, so suppose that we randomly chose a student from the class. Find the following probabilities. So what's the probability that we're going to pull somebody who can taco tongue? Well, let's look at the total number of people who can taco tongue, which is 20. And then how many people total do we have? Okay, so we have 20 out of 30. Okay. Let's look at how many people can evil, or the probability of pulling an evil eyebrow. So if we look at the total number of evil eyebrows, we've got 18 out of how many total? 30. Okay. Same concept's going to go for the next two. So how many what's the probability of them not being able to taco tongue? So we're looking at no taco tongue, which is 10 out of 30. What's the probability of no evil eyebrow? That's 12 out of 30. So fairly simple so far, right? Now, we're introducing this conjunction. We've got this and, okay? And is going to be something where they both cross over. They have to have both conditions. It can't just be one or the other. Okay, so yes, they taco tongue, and yes, they evil eyebrow. So where do they both overlap? At 15, right? So this is going to be 15 out of 30. Yes for evil eyebrow and no for taco tongue. Yes for evil eyebrow, no for taco tongue. So that's going to be 3 out of 30. Yes to taco tongue and no evil eyebrow. That's going to be 5 out of 30. And the last one, no taco tongue and no evil eyebrow, which is going to be the 7 out of 30. Suppose that we randomly choose a student from class. Find the probabilities. So the probability of an evil eyebrow, okay? So how many people did we have that could evil eyebrow? Well, 18 out of the 30, right? Oops, not the highlight. 18 out of the 30. How many could not evil eyebrow? Yep, 12 out of the 30. Now, here's another conjunction. It says or. Or means adding. Or means adding. That's the same as it used to be in geometry, but I'm going to show you again. So, if they yes evil eyebrow, that's 18 out of 30, right? Or they no evil eyebrow, that's 12 out of 30. Well, what's 18 plus 12? Okay, and 30 out of 30 is 100% of them are either able to do it or not able to do it, right? These are called mutually exclusive events. Okay, because either you can do it or you can't. You can't sort of do it. You know what I mean? Like not in this case. Okay? So mutually exclusive means that they cannot occur at the same time. So looking at number 4, it says, suppose we randomly choose a student from the class. Find the following probabilities. So yes, they can taco tongue. Well, looking at the total number of people who can taco tongue, that's 20, right? I'm sorry. Yeah, that's 20. And then how many people can evil eyebrow? That's 18 out of 30. Now my question is, are there some people who can do both, and are there some people who can only do one or the other? Yes. Okay, so in this instance, we're going to say 20 out of 30 plus the 18 out of 30, but we're going to subtract the overlap. And what I mean by that is, you notice how we have that 18 that we're adding, and we have that 20 that we're adding? Well, what numbers do they both include? That 15. So we're going to have to subtract that 15 out of 30, because otherwise what's happening is we're counting somebody twice. Okay? So we've got to make sure that we don't do that. So if we do 20 plus 18 minus 15, that's going to give me 23 out of 30, right? And so one formula that you want to make sure that you write down is the probability of A plus the probability of B minus the probability of the intersection of them. So the intersection means both of them occurring. This is just like an upside down U. This is called the intersection, also known as when both occur. Okay? I'm checking your understanding. All right, so the big takeaways from this are the two-way table, which was the little 4 boxes, and we had 1, 2, 3, 4. We had probability of B, probability of A, and A naught, and B naught. That little C is what that naught represents. We also had a Venn diagram. And so we had the 2 circles and where they overlap. Okay, and then the number that was outside was where it didn't have any of those conditions. The next thing that we learned about was the general addition rule. Super fancy name. So if I have P, the probability of A or B, that means that I'm going to take the probability of A plus the probability of B minus the probability of A and B, also known as the intersection of A and B. Which means that if events A and B are mutually exclusive, They cannot occur together. So that means that the intersection of these two is going to be equal to 0.